Okay, so we have two questions left here from these exercises, and that is, for example, suppose that your vertices are at plus or minus 7. Your vertices are at plus or minus 7, comma 0. Are at plus or minus 7, comma 0. And your eccentricity is 4/3. And you know that your eccentricity is basically nothing but just a ratio. So E is equal to 4/3. So what this tells me is that basically these points are along the x-axis, and so that means that the transverse axis of this hyperbola is along the x-axis, and so the equation of this hyperbola is going to be x squared by a squared minus y squared by b squared is equal to 1. So we keep this for later. Moreover, this tells me that since the vertices are at a distance of basically a units away from the center, so my a is equal to 7. And you know that E is basically equal to C by A. So that means that, and that is equal to 4/3. So that means that C by A is equal to 4/3. And since A is equal to 7, I can write C divided by 7 is equal to 4/3. And so C is equal to 7 times 4 divided by 3. And C is equal to 7 times 4 divided by 3, and that is 4 times 7 is equal to 28, and 28 is of course not divisible by 3. 7 times 4 is equal to 28 by 3, 28/3. So your C is equal to 28/3. C by A is equal to 4/3. A is equal to 7. So C divided by 7 is equal to 4/3, 28/3. Okay. So your A is equal to 7, C is equal to 28/3. Now I need to calculate my B. I know that B is equal to the square root of C squared minus A squared. C squared minus A squared, or B squared is equal to C squared minus A squared. To calculate B, I can write B squared is equal to 28/3 whole squared minus A squared, which is equal to 49. Now 28 squared is equal to 28 times 28, I don't know, it's 64, 6. 16 plus 6 is equal to 22. 0, 16, 1, 4, 5, 4, 8, 7, 784. 784. So B squared is equal to 784 divided by 9 minus 49. And that is equal to basically 784 minus 4 times 49 is equal to 81, 8. 36 plus 8 is equal to 46, 44, 441. 441. Now 784 minus 441 is equal to 1 is equal to 3, 4 and 343 is equal to 343 ninths. That is B squared. I don't think we are going to need B squared. We are going to need the B squared. So B squared is equal to 343 ninths. So now what we can do we can write our equation. So we said that x squared by a squared, x squared by 49 is equal to, minus y squared over b squared, which is equal to 343 by 9 is equal to 1. And but of course I can calculate this as, let me see how they have written this equation number 14. They've written this as x squared by 49 minus 9 times y squared, 9 times y squared over 343 is equal to 1. They have written it this way, which is of course not a bad way of writing it. So it's okay. So that is that, and the next question is 296. The next question is question number 15. Question number 15. So suppose that your foci are at 0, plus or minus square root of 10, and the hyperbola is passing through 2, 3. So if that is the case, so this tells me that basically the foci are along the, so your x coordinate is 0. So the foci are along the y-axis. That means that the transverse axis is along the y-axis. And so what that means is that I can write y squared by a squared minus x squared by b squared is equal to 1. Now, since this hyperbola passes through this point 2, 3, I can write basically 3 squared is equal to 9 over a squared minus x squared, which is 4 over b squared, is equal to 1. That is one thing that I have over here, so that is basically, I call this equation number 1. Moreover, since the foci are at a distance c away from the center, that means that my c is equal to square root of 10. And what that means is that, of course, we have this relationship between a, b, and c, which is b is equal to the square root of c squared minus a squared. And that means that b squared is equal to c squared minus a squared. And since c is equal to the square root of 10, c squared is equal to 10 minus a squared is equal to b squared. So b squared is equal to 10 minus a squared. So I can write, so for example, I can call this equation number 2, and what I can do is that instead of b squared over here, I can write 10 minus a squared. And so over here I can write 9 over a squared minus 4 over 10 minus a squared is equal to 1. This is a 9, of course. Sometimes I get confused by my own handwriting. So now what I can do in order to solve this equation is that I can write this as 9 by a squared minus this is 4 by 10. This is 4 by 10 minus 4 by 10. No, I cannot do that. I cannot do that. I'm sorry. That was a very, very bad mistake that I made. So what I can do in order to solve this problem, it's a little bit tricky, but there is a way to solve the problem. You see, you have to somehow get your a squared out of the denominator so you can solve the problem. Because if I want to solve this problem, there is actually one way. Let's try that. I could write the denominator. I can write it as a squared times 10 minus a squared. And then that would give me basically 9 times 10 minus a squared minus 4 times 4 times a squared is equal to 1, which means that 9 times 10 minus a squared minus 4 times minus 4a squared is equal to a squared times 10 minus a squared. And then I would have to multiply all of these out, and then I will get over here, I will get negative a raised to the power 4. I can do this, but it's a little bit. Now I will leave this over here for now, but I want to show you another thing using this equation, and then if that doesn't work out, we will come back over here and solve the problem this way. So what I want to do is that I write 10 minus a squared as, for example, b. I write 10 minus a squared as, for example, x, as x. If 10 minus a squared is equal to x, then a squared is going to be equal to, and therefore a squared, negative a squared is equal to x minus 10, and so positive a squared would be equal to 10 minus x. So what that means is that now I can write a squared as 10 minus x, and basically I can write a squared as 10 minus x, and a squared as 10 minus x, and 10 minus a squared I can write it as x. So the equation becomes 9 over a squared, which is equal to 10 minus x minus 4 times 4 over 10 minus a squared, 10 minus a squared, which is equal to x, is equal to 1. Okay, and now if I multiply all of these together, x times x is going to be x squared, a second degree equation instead of a fourth degree equation. Of course, these are basically the same ways of doing the same thing. But this seems to be better. I mean, this is much more straightforward. So then I can write the denominator as the LCM. I write 10 minus x times x, and then that is 9x minus 4 times 10 minus x is equal to 1, and so 9x minus 4 times 10 minus x is equal to 10 minus x times x. And so what that means is that 9x minus 40 plus 4x is equal to 10x minus x squared. Take everything to one side, x squared minus 10x plus 4x plus 9x minus 40 is equal to 0. And so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, x squared negative 10x, 4x, 9x minus 40. So then x squared, that is 13 minus 10 is equal to plus 3x minus 40 is equal to 0. And now this equation, and now I can solve this equation very easily, the way that I usually do solve a second degree equation. So 40 is the same thing as basically 4 times 10. So I can write 4 times 10 or 2 times 20 or 8 times 5, for example. 8 times 5. 8 times 5. Now 8 times 5 is equal to 40, and 8 times negative 5 is equal to negative 40, and 8 minus 5 is equal to positive 3. So using these two numbers I can rewrite this equation, meaning that I can write x squared plus 8x minus 5x minus 40 is equal to 0. And so from these two equations, for example, if I take an x out from these two terms, x plus 8 minus 5 times x plus 8 is equal to 0. That gives me x minus 5 times x plus 8 is equal to 0. And what that means is that either x minus 5 is equal to 0 or x plus 8 is equal to 0. So that gives me x is equal to 5, or this is x is equal to negative 8. Now you need to basically, whether you accept both of these answers or reject one of them depends on what you have done here. Basically over here we have said that x is equal to 10 minus a squared. X is equal to 10 minus a squared. So now if basically if x is a positive number, if basically you see over here, if a squared is or if I write this the other way around, I can write it as negative a squared is equal to basically x minus 10, or a squared is equal to 10 minus x. Now a squared has to be greater than 0. A squared has to be greater than 0 because a is a distance, and so whatever the number might be, whether positive or whether a is positive or negative, when you raise it to the second power, it has to give you a positive number. So that means that a squared has to be greater than 0. Now for a squared to be greater than 0, 10 minus x has to be greater than 0. And that means that negative x is greater than negative 10, or x has to be less than 10. X has to be less than 10. So if x is less than 10, then basically a squared is going to be greater than 0, which means that both of these answers seem to be the right answers. So now we will take a look at them one by one. X is equal to 10 minus a squared. So if x is equal to 10 minus a squared, that gives me basically, if x is equal to 5 is equal to 10 minus a squared, or I can take a squared to the other side, a squared is equal to 10 minus 5. So a squared is equal to 5, and a is equal to square root of 5, which is acceptable. There's nothing wrong with it. And this will also be acceptable because if I write x is equal to 10 minus a squared, and then if x is equal to negative 8 is equal to 10 minus a squared, take this to the other side, a squared is equal to 10 plus 8, and we see that a squared is equal to 18, so a is equal to, a squared is equal to, or let's say a is equal to, or a is equal to the square root of 18, which is the square root of 9 times 2, 9 times 2, which is equal to 3 square root of 2. So I have these two values for a. I have these two values for a. Either a is equal to 3 square root of 2, or basically or square root of 5. Now what I need to do is find two values based on these two values of a. I need to find two values for b, and that we should find somewhere over here. That we should find somewhere over here, this equation. B squared is equal to 10 minus a squared. So we said that b squared is equal to 10 minus a squared. So if basically there are two cases, if a is equal to the square root of 5, then b squared is equal to 10 minus a squared, then b squared is equal to 10 minus 5. So b squared is equal to 5. That means that b is equal to b squared is equal to 5. That means that b is equal to the square root of 5. If a is equal to square root of 5, b is equal to square root of 5. And if a is equal to 3 square root of 2, then again b squared is equal to 10 minus a squared is equal to 10 minus a squared. So b squared is equal to 10 minus a squared over here is 9 times 2 is equal to 18, which is basically b squared is equal to negative 8, which is not acceptable. So the only answer that I can accept is a square root of 5, b square root of 5. Now, over here we said that y squared over a squared, we said that y squared over a squared minus x squared over b squared is equal to 1. So then I can write y squared over a squared, which is equal to 5, minus x squared over 5 is equal to 1, and that is the equation of your hyperbola. Number 15, y squared over 5 minus x squared over 5 is equal to 1. So the next thing that we have here is some miscellaneous examples. 17, 19, not much really. We will go through them as well, and then after that we have some miscellaneous exercises as well. We will do them as well, and then we are done with this chapter. So I'll see you in the next video.